Hey everyone, in programming we're always building things. But have you ever stopped to think, how does a brand new digital thing, an object, know what it's supposed to be from the very first moment it exists? Well, that's the job of a powerful little tool called a constructor.
I mean, seriously, think about it. When you create a new character in a game, it needs health points, a name, and an inventory, right? Or when a new user signs up, their account needs a username and a default status. Where do all these initial, essential details come from? Because without them, the object is just an empty, useless shell.
The answer to that question is the constructor. It's basically the blueprint for how all new objects get started.
So here's the formal definition. A constructor is a special kind of method that runs automatically the instant an object is created. Its one and only job is to set up that object's initial attributes so it's ready to go from the start. A great way to think of it is like the very first station on an assembly line. It's where the basic frame of our object is put together and all its essential parts are installed.
Okay, so theory's great and all, but let's see how this actually works in code. We're going to look at a constructor in action by building a car object.
We'll use a car class. It's a classic example for a reason, because everyone knows what makes a car. It needs a make, a model, and a year. These are going to be our object's attributes.
In Python, the constructor is this special method with a kind of funny name, __init. Notice it takes a few parameters. There's self, which is just a reference to the object we're creating, and then make, model, and year. The code inside simply takes the values we provide and assigns them to the object's attributes. This makes sure every single car we create will have this essential information.
Now let's actually put it to use. When we write this line to create a myCar variable, we're calling the car class and passing in Toyota, Corolla, and 2022. And behind the scenes, this automatically triggers our _init method.
The constructor pretty much acts like a receiver. Toyota gets passed right to the make parameter, Corolla goes straight to model, and 2022 is assigned to year. It's this direct mapping that makes sure the right data goes to the right place every single time.
And what's the result? Our new myCar object is born fully formed. It's not just an empty shell, it's a specific 2022 Toyota Corolla. The constructor guaranteed that it started its life in a valid, predictable state.
But it turns out, not all constructors work the same way. Just like there are different manufacturing processes for different products, there are different types of constructors for different coding needs.
We really have two main types. On the left, you've got the default constructor. This one takes no arguments and just builds a generic, standard issue object every time. On the right, you have the parameterized constructor, which is what we just used for our car. It accepts inputs, letting us customize each object as it's built. The choice is a classic trade-off. Do you need simplicity or do you need control?
So we've covered the what and the how, but let's get to the why. Why should you, as a programmer, care so much about this? Well, because using constructors properly is a hallmark of clean, reliable code.
It all comes down to three huge benefits: proper initialization, better encapsulation, and way more flexibility.
First up, initialization, and this is the big one. By using a constructor, you prevent objects from existing in some weird, broken, or incomplete state. You guarantee that every single object you create is valid and ready to be used right away, which helps prevent a whole class of bugs.
Next, encapsulation. Now this is just a fancy word for good organization. Think of a class as a self-contained blueprint. The constructor keeps all the assembly instructions inside that blueprint, instead of having them scattered somewhere else in your code. Everything you need to know about creating an object is in one place.
And finally, flexibility. This is where parameterized constructors really shine. That single car class blueprint can be used to create a ton of different cars. A Ford, a Honda, a Tesla, each with its own unique attributes, all from one single piece of code. It's incredibly powerful.
So the constructor is the gatekeeper of an object's birth, but an object also lives a life and eventually gets destroyed to free up memory. That leaves us with the question: if init is the first chapter, what methods write the rest of the story?